So I'm gladly introducing myself. My name is Lermay Ansi Mayo from the section of CE2C Batch 2. In this video, I would gladly share my knowledge and explanation in solving 4 problems.
Problem number 1. In how many ways can 5 starting positions on a basketball team be filled with 8 men who can play any of the positions? As we can see, we have 5 different starting positions, so ordering the player is a must. Considering that the order is important, we need to use permutations. According to Theorem 2.2, the number of permutations of n distinct objects taken R at a time is the permutation is equals to the n factorial all over the n minus r factorial. So in this problem, n will be equals to 8, which indicates the group of basketball players, while the r will be equals to 5, which indicates the starting positions. Substituting it in our formula, we have the permutation is equals to the 8 factorial all over the 8 minus 5 factorial will be equals to 8 factorial all over the 3 factorial, so which results to 6,720. Therefore, there are 6,720 ways can 5 starting positions on a basketball team be filled. Problem number 2. Find the number of ways that 6 teachers can be assigned to 4 sections of an introductory psychology course if no teacher is assigned to more than one section. This is likely similar to the first problem we solved. In this case, we will going to use the same theorem. The permutation is equals to the n factorial all over the n minus r factorial. We need to find the number of arrangements of 4 teachers selected from a group of 6 teachers. In the order is important, so we are going to use permutations. So n will be equals to 6, indicates the teachers to be assigned. R will be equals to 4, which indicates the sections of an introductory psychology course. Substituting it in our formula, we have the permutation will be equals to the 6 factorial over the 6 minus 4 factorial would be equals to 720 all over 2 equals 360. Therefore, there are 360 ways to assign 4 teachers to these sections. Problem number 3. In how many ways can 4 boys and 5 girls sit in a row if the boys and girls must alternate? As we can see from the question, there are a total of 5 girls and 4 boys indicated. The arrangement must be alternate, so the girls would be at the beginning and in the end of the row. I will use the variables G to indicate girl and B to indicate boy. Analyzing this, the first thing we need to do is to place the girls in their places in a row, just like this. I leave some spaces in between because the arrangement must be alternate, so the spaces will be filled by the boys later on. The number of permutations of these 5 girls is 5 factorial would be equals to 120, which means there are 120 ways for the girls to arrange themselves. Just like we did in the first step, we also need to place the boys on their places in between the girls for us to know the number of permutations as well. Just like this. So the number of permutation for the boys would be 4 factorial would be equals to 24, which means there are 24 ways for the boys to arrange themselves. According to Rule 2.1, which is often referred as the multiplication rule, if an operation can be performed in n1 ways, and if for each of these ways a second operation can be performed in n2 ways, then the two can be performed together in n1 multiplied by n2. So n1 would be equals to 120, indicates the number of permutation for girls, n2 is equals to 24, indicates the number of permutation for boys. Performing the rule, we have 120 multiplied by 24 would be equals to 2,880. Thus, the 4 boys and 5 girls can sit in a row with an alternate arrangement in 2,880 ways. Problem number 4. If 3 books are picked at random from a shelf containing 5 novels, 3 books of poems, and a dictionary, what is the probability that A. The dictionary is selected, and B. 2 novels and 1 book of poems are selected? So there was a total of 9 books placed in the shelf, 5 novels, 3 books of poems, and 1 dictionary. And we need to pick 3 books randomly from that shelf. The order is not important because we are choosing here randomly, so we use combinations to calculate the number of ways of choosing 3 out of 9 books. So the formula for combinations will be n factorial all over r factorial multiplied by the n minus r factorial, wherein n would be equals to 9, which is the total number of books, and r would be equals to 3, the total of books we randomly pick. Substituting that, 9 factorial all over 3 factorial multiplied by the 9 minus 3 factorial, we get 84, which means we can choose 3 books out of 9 books in 84 ways. So for the letter A, what is the probability that the dictionary is selected? We need to find first the probability that a dictionary is selected. So among the 9 books on the shelf, there's only 1 dictionary. So we need to use combinations to calculate the number of ways that we can choose 1 dictionary, considering that the order is not important. So using the formula in combinations, we have 1 factorial all over 1 factorial multiplied by 1 minus 1 factorial equals to 1, which means there is 1 way we can choose dictionary. So analyzing that, there is 1 dictionary on the shelf, so we consider the other 8 books as non-dictionaries. So the number of ways to choose 2 books out of 9 dictionaries is, substituting it to the formula of combination, we have 8 factorial all over 2 factorial multiplied by 8 minus 2 factorial equals to 28, which means there is 28 ways to choose 2 books out of 9 non-dictionaries. If the first operation can be performed in 1 way, which the number of ways to choose 1 out of 1 dictionary, and for each of these ways, the second operation can be performed in 28 ways, the number of ways to choose 2 out of non-dictionaries, then these 2 operations can be performed together as n1 multiplied by n2. So substituting it to the formula, we have 1 multiplied by 28, we get an equal of 28. So the probability would be equals to 28 all over 84, and that would result to 0.333. So that's the probability in selecting dictionary. For the last problem, we have what is the probability that 2 novels and 1 book of poems are selected? So in here, we need to find the probability. So there are 5 novels on the shelf. We need to use combinations to calculate the number of ways that we can choose 2 novels. So we use combinations. Using this formula, we have 5 factorial all over 2 factorial multiplied by 5 minus 2 factorial, which is equals to 10, which means the number of ways to choose 2 out of 5 novels is 10 ways. We also need to get the number of ways to choose 1 out of 3 book of poems. So using also the combinations, we have 3 factorial all over 1 factorial multiplied by 3 minus 1 factorial equals to 3, which means that the number of ways to choose 1 out of 3 books of poems is 3 ways. So if the first operation can be performed in 10 ways, which means the 10 ways is the number of ways to choose 2 out of 5 novels, And for each of these ways, the second operation can be performed in 3 ways, which means this is the number of ways to choose 1 out of 3 book of poems. Then these 2 operations can be performed together in n1 multiplied by n2. So we can perform it just like this. So we have 10 multiplied by 3. That will be equals to 30. So 2 novels and 1 book of poems can be selected in 30 ways. So the probability of choosing 2 novels and 1 book of poems is, we have 30 all over the 84, we get 0.3571. So that's the probability.